Welcome to lesson 106 of Saxon Course 2. In this lesson we're going to solve literal equations, transforming formulas, and we're going to look at roots a little bit more. See if we can find cube roots of a number. Okay, so a literal equation is an equation that contains letters instead of numbers. We can arrange them or transform them the same way we do the numbers that we've done in the past, the constants and things like that. We've done this before, but we're going to use just simply letters now. Okay, so looking at this here, it says we need to solve for x. So we want to isolate the variable x. So we need to get the other two, a and b variables, on the other side of the equal sign. So x and a, what's happening to a? Is it being added or subtracted from x? It's being added. So we do just like we do with the numbers. We're going to subtract a from each side. So we end up with x equals b minus a. That's it. You're done. You can't solve it any more than that because you don't know there's no numbers to plug in there. So that is the solution. X equals b minus a. Okay, let's look at another one. So how would you do this one? See if you can figure it out before I show you. You should know how. Again, you want to isolate the x. So as you can see, the x and the a are being multiplied. So to get the a on the other side, I have to divide by a and divide by a. That eliminates the a on this side, leaving just the x. So I have x equals b divided by a, and that's our answer. Pretty simple stuff. You understand it? Shouldn't be too bad. So let's see if you can solve for w on this one here. Same thing, they're just trying to confuse you a little bit because they're flipping it around. So we need to get w all by itself. So what are we going to do? Pause it, write your answer. Okay, we're going to, the L and the W are being multiplied. So to get the L on the other side, we're going to divide by L and divide by L. So these get canceled out, so you end up with W equals A divided by the L. All right? Not too bad, pretty easy stuff. Okay, so moving on now. Let's talk about a perfect square of 25. 25 itself has a perfect square of 5 times 5, which equals 25, and also negative 5 times negative 5, which equals 25. So the equation x squared equals 25 has two solutions. It has 5 and negative 5. But when we see something like this, 25, and it's underneath the radical symbol of the square root right here, then the answer is only positive. And they call that the principal square root. So the principal square root of the square root of 25 equals 5 only. But in this equation right here, you'd have both 5 and negative 5. So what are the square roots of 5? Well, if you remember right, this 5 is not a perfect square root. We know that this equals 2. We know that. But that doesn't. You can't. There's no perfect. It's not a perfect square. So in this case here, I told you we leave it as the square root of 5. But there's two answers to that. You also have to have the negative square root of 5. So when you see what are the two square roots of 5, and it's not a perfect square like this, then you're going to have to do it like this. Okay. All right. So the two square roots of 5 are the square root of 5 and the opposite of the square root of 5, which is the negative square root of 5. All right, so a radical symbol can be used to indicate other squares besides square roots. In this case, we're going to talk about cubes. We got this little teeny 3 here, which is the index. And what that says is that we want the square root of 64, but we don't want just the square root. We want the cube root. So we want what 3 numbers instead of 2? Normally, the square root would be 8, right? 4 times 4. But what times what times what equals 64? What's the cube root? Well, that would be 4 times 4 times 4. So the cube root of 64 would be 4. Now, can we also use negative 4? And if we can't, why not? Well, we can't because we know that negative 4 times negative 4 times negative 4, if we have an odd number of negative signs, we know our answer is going to be negative. And we can't use a negative for a principal square root. We can only use a positive. So, no, the cube of negative 4 is a negative number. It's negative 64. So it's not. It doesn't work for positive 64. All right, let's practice a couple here. So what would be the cube root of 1,000? What number times itself 3 times equals 1,000? And then on B, what number times itself 3 times equals negative 27. Okay, you should have come up with 10, and you should have come up with negative 3. I think those, you probably did those mentally. Nice job. All right, let's see if you can do this one last practice set. Do it, solve it, pause the video. Okay, so A plus B equals C. We want to solve for A. That's the first thing you've got to see. You don't want to solve for C. That's normally what we would do, but we don't want to do that. We're going to solve for A. So A plus B equals C. So we've got to move our B over, so we're going to do minus B minus B. So we're going to end up with A equals C minus B, and that's your answer. All right, hopefully that all made sense. Wasn't too bad. Pretty easy lesson. Here's your TIDs. Get them done. Bring them in tomorrow, or submit them tonight. Bring your questions tomorrow. We'll work on the math as a class. Thank you.